2.2 Conditional Statements. And our objective in this lesson is to learn about conditional statements and their parts, and we will get into all of those. What you should have noticed with a lot of our postulates and things that we have been doing is that we have been using if-then statements. Now, these should not be new to you. You use these in science. When you set up an experiment, the hypothesis for your experiment, if I do this, then this happens. We're going to be talking about if-then statements and their truth values, which is exactly what it sounds like. Okay, conditional statements are simply if-then statements. And of course, we have a symbol for them. This P and the arrow pointing at the Q. This reads if P, then Q, or P implies Q. The first part of this is our hypothesis. This is part P. It always follows the if portion, and the hypothesis is your requirement. This is what is required if this happens, if angles are a linear pair. The conclusion is the Q part, and it always follows the then statement. This is the result. If angles are a linear pair, then they are supplementary. Okay, so if the requirement is met, if you meet the requirement, then the result happens. We can also represent these as a Venn diagram, and you can see that the set of things that satisfies the hypothesis, so our hypothesis is P, our hypothesis set is inside the set of things that satisfy the conclusion. Okay, the conclusion is out here. So the things that will satisfy your hypothesis are inside the set of the results. Your requirements are inside your results. Let's take a look at these. Examples are always a good way to go. Find the hypothesis and conclusion of the conditional. If an animal is a robin, then the animal is a bird. So here's our if. An animal is a robin. There's our hypothesis. Then is the conclusion. The animal is a bird. So pause the video and you do the next one. That should have been pretty straightforward. We have if an angle measures 130 degrees, so our hypothesis, our requirement is our angle measures 130 degrees, and the conclusion or the result is the angle is obtuse. All right, let's look a little further into these. Writing a conditional. Now, sometimes our sentences don't always come with the if and then portion. So we are going to have to figure out where that is. So our sentence here says vertical angles share a vertex. So figure out where is the requirement and where is the result. So we have two separate ideas here, vertical angles and vertex. So I am going to split my sentence right there. So we identify our hypothesis, and put it with an if statement. If two angles are vertical angles, we could put angles in there, I would, or it doesn't matter if they're vertical, then our result, they share a vertex. All right, go ahead and pause the video and you try to do the next one. Okay, so you should have read dolphins are mammals and split your ideas here. We have dolphins and then we have mammals. So sometimes you have to add some words to make these work because you can't just say if dolphin then mammal. What's going to make that into a nice sentence? So for our hypothesis here, we wrote if an animal is a dolphin, and then the conclusion, so that's our requirement, we've got a dolphin, then it is a mammal. That's the result. If we've got a dolphin, then we know it's a mammal. So far these should be pretty easy. Let's talk about truth value. And this is going to be one of the more challenging things that we do with conditional statements is truth value. And your conditional is either true or false. If your conditional is true, then every time the hypothesis is true, the conclusion is true. This isn't necessarily how it always happens. So a counterexample can help you determine whether your conditional is a true conditional or not. You can show that your conditional is false if you find one, just one counterexample where the hypothesis is true and the conclusion is false. That will make your entire conditional false. Let's look at a couple of these. If a woman is Hungarian, then she is European. Now the book likes to tell us that this is true because Hungary is a European nation. So Hungarians are Europeans. This is one of my complaints about this book. You can be Hungarian and not necessarily be European. Can you think of an instance? What if someone was born in Hungary and then immigrated to another country, say the United States? You could be Hungarian and then be American. So, can you see why the book wants this to be true? Hungary's in Europe, so yes, Hungarians are Europeans. You have to be very careful about these statements. Let's look at the next one. If a number is divisible by 3, so we are looking at numbers that are divisible by 3, that's our requirement. Our result is then it is odd. So let's start looking at numbers divisible by 3. Those are our, first it seems reasonable. Those are our multiples of 3. So we have 3, 6, 9, 12, I see 2 of them there that are not odd. So any one of these will make our conditional false. So we cannot say this. 6 is a counterexample, 12 is a counterexample. You don't need both of them, you only need one. All right. Oh, it's your turn. Pause the video and do the next couple of problems. Okay, these are kind of fun. A was, if a month has 28 days, then it is February. And you might be inclined to go, well, yes, February has 28 days. But are there any months? You have to ask yourself, does January have 28 days? Yes. As a matter of fact, all months have 28 days. A better way to write this problem would have been if a month has no more than, and we can't say 28, about 29 days, then it is February. So no more than would be less than or equal to, right? We can't be any bigger than 29, because don't forget leap year. And the second one, if 2 angles form a linear pair, then they are supplementary. That is true. We know that's true. It's our linear pair postulate. But you should think about all angles that form a linear pair. And what's the definition of linear pair? Adjacent and supplementary, right? And how do we make adjacent and supplementary? Supplementary means 180 degrees there. So I can't think of any way to make a linear pair that is not supplementary. So this is true, and we know it's true because it's our linear pair postulate. So be careful with these, and the challenge is going to be thinking of that instance where it's not true. And sometimes there's only one, but one is enough. All right, let's look at statements related to our conditional statement. All right, negation means not, right? And if we negate our statement, it is the opposite of the statement. This symbol reads not P. So if our statement, the sky is blue, we would say the sky is not blue. Now, negating your conditionals, be careful that you are saying the opposite and not just putting in the not. Most of these are fairly straightforward, but you do have to be careful, and we'll see a couple of those examples as we go. So we know our conditional statement. Conditional statement is just if then, right? We use our hypothesis and our conclusion, and we just say, for example, if the measure of angle A equals 15 degrees, then angle A is acute. So we've got our 15 degrees and acute. Next is a converse. And in a converse, we just exchange the hypothesis and conclusion. So switch. We switch our hypothesis and conclusion. So let's look here. If angle A is acute, there's our acute, then the measure of angle A is 15 degrees. Okay, do you see that we just switched our hypothesis and conclusion? Now you should be thinking about that and going, that's not necessarily true. We'll get to that. All right, next is the inverse. And for the inverse, we negate both hypothesis and conclusion. So this is not of your conditional statement. So let's look at this. If the measure of angle A is not 15 degrees, then it is not acute. Do you see how that's just our conditional up here? Our conditional was if 15 degrees, then acute. This is if it does not measure 15 degrees, then it is not acute. And notice over here we have our symbols, not P, then not Q. And finally, our contrapositive, we negate both the hypothesis and conclusion of the converse. I want to underline conditional up here. So we negate our converse. This one is not the converse. So we have to have our hypothesis and conclusion switched and then negate that. So if we look here, we have if angle A is not acute, then it does not measure 15 degrees. And the measure of angle A is not 15 degrees. So you have to be careful with these. If you pay attention and think about what's my hypothesis, what's my conclusion, then they're easy to write, but you have to be careful. Okay. Equivalent statements have the same truth value. So let's look at our statements here. Our conditional, if your angle measures 15 degrees, then it's acute. That is true. And the converse of that, which is where we switch them, if it's acute, then it measures 15 degrees. Well, an angle that measures 14 degrees is still acute, so this one is false. Your inverse, how do we make an inverse? That's right, we negate the conditional. Your inverse, if the measure of angle A is not 15 degrees, then it is not acute. Well, again, what if we have the measure of an angle that's 14 degrees? That's not 15, but it's still acute, so this statement is false. We could put our... So, what if the measure of your angle equals 14 degrees? This one has the same, we can prove it with the same counter example. Our contrapositive, how do you make a contrapositive? By negating your converse. If angle A is not acute, then the measure of angle A is not 15 degrees. Now that is a true statement, because angles that are not acute are going to measure from 90 to 180 degrees. So we can say that it's not going to measure 15 degrees. There's other results that are true, like it does not measure 14 degrees, but that is not what our requirement. Our requirement here is that it's not acute. So what does this mean to us? A conditional and its contrapositive are equivalent statements. They are either both true or both false. This is also true for the converse and inverse are equivalent statements. They are either going to be both true or both false. So when you match these up, if you get different answers for those, you should go back and check and see if you have any counter examples that you can find. So let's look at writing truth values of statements. We want to know the converse, inverse, and contrapositive of the following conditional. Find the truth values. If it's false, give your counter example. So we have our conditional here. This is our conditional, our if-then statement. If the figure is a square, there's our requirement, our hypothesis. What's the result? Then the figure is a quadrilateral. All right, let's look at this. Hypothesis is square. Conclusion, quadrilateral. To write the converse, we are going to flip those. So we have, if the figure is a quadrilateral, then the figure is a square. Is that a true statement? Now our requirement is quadrilateral. Is every quadrilateral a square? No, it's not. Rectangles, rhombus, trapezoid, there it is, it's trapezoid. Trapezoid, kites, we don't know about kites yet, maybe you do, but kites, all of those are quadrilateral, some random 1, 2, 3, 4 shape that doesn't fit in any of our specific ones. There are so many counterexamples, totally false. All right, so there's our converse. Now let's write the inverse. The inverse negates both the hypothesis and the conclusion. So if our figure is not a square, then it is not a quadrilateral. We already proved this one false up above. And we expect this one to be false because our converse was false. Converse and inverse are equivalent statements. We expect both of these to have the same truth value. And this one is for the same reason. Rectangle, random quadrilateral, parallelogram, rhombus, trapezoid, everything that we put up there. There are so many things that are a quadrilateral that are not a square. So if you're not a square, then you're not a quadrilateral. That is absolutely false. All right, and then we write our contrapositive. The contrapositive is the negation of our conditional, right? This is not or the negation of our converse. This is not the converse, sorry. Let's put some more. Switch your conditional. That's how you do a converse. How do we do an inverse? An inverse is just not your conditional. And then the contrapositive is just not your converse. So let's look at this one. If the figure is not a quadrilateral, then the figure is not a square. So our requirement is not a quadrilateral. That means anything, any shape that does not have four sides. So triangle, hexagon, any of those, decagon. It is not a square. This is absolutely true. And we expected it to be true because our conditional is true. So we expect that to be true. Because conditional and contrapositive are equivalent statements, and converse and inverse are conditional statements. All right. There's not a lot of space for you to do number 4 down there, but go ahead, pause the video, do the last problem, and we will come back and discuss it and finish this lesson. All right, I had to squeeze mine in here a little bit. Sorry, there's not enough room. So our conditional says if a vegetable is a carrot, then it contains beta carotene. Now, the first thing you have to know is what beta carotene is. Beta carotene is one of those, it's not a vitamin. It's a nutrient. We'll call it a nutrient. Beta carotene is a nutrient that's found in red and orange pigmented fruits and vegetables and dark green lettuces like spinach and things like that. So if you're a carrot, you contain beta carotene. That's true. One of the fruits and vegetables that does. Now we write our converse. Converse, remember, we switch our conditional. So if a vegetable contains beta carotene, and yeah, I left some words out here to fit it in, but you shouldn't do that. If a vegetable contains beta carotene, then it is a carrot. And that's false because our requirement now is beta carotene. And we looked up on the internet and found out that spinach and squash and cantaloupe and all kinds of other things contain beta carotene. So that one is false. Now our inverse, remember, is we negate our conditional. So if a vegetable is not a carrot, then it doesn't contain beta carotene. Well, there's lots of vegetables that are not carrots that still have beta carotene. We just gave examples: spinach, squash, cantaloupe, sweet potatoes. And then contrapositive, but we expected the inverse. Let's go back to the inverse. We expected our inverse to be false because our converse was false. And remember, converse and inverse are equivalent statements. So not surprising that that one is not true. And our contrapositive, if a vegetable contrapositive is just the negation of your converse, right? If a vegetable doesn't have beta carotene, then it is not a carrot. So this item that we're looking at does not have beta carotene. That's our requirement. The result is not a carrot. That is a true statement. We could change our result. It's not spinach. It's not squash. That's not what we're worried about. What we're worried about is the true hypothesis. If your vegetable doesn't have beta carotene, all right, we're holding something here in our hand that does not have beta carotene, it's not a carrot. That is a true statement. And we're not surprised by that one either, because we know that our conditional and our contrapositive are equivalent statements. So since our conditional was true, our contrapositive should also be true. All right, these truth values should be the most challenging thing that you have to do. I would keep these parts of your notes handy right here. This is good stuff. This is the explanation of how to write them and gives you examples. And this is a really nice example right here. Very neat and tidy, right? And shows you where the knots come in, right? This is just not. Shows you how to write these. They're easy to compare. I would keep these notes, even when we move on out of chapter 2. This section right here would probably be a good one to keep handy so that you can think about the different, have good examples of the different forms of conditionals and converses and inverses and contrapositives. So this homework should not be overly difficult. Writing the different forms of your statements is just a matter of thinking about it, identifying your hypothesis and conclusion, and knowing where to put the pieces, which you have good examples for. The challenging part of this is finding those counterexamples, and especially with like the geometry problems. When you were thinking about, the beta carotene, as long as you know what beta carotene is, hey, it's in carrots, it's in spinach. But when you actually have to think about, points, lines, and planes, and everything that we are making from those, and all the rules we have, you're really going to have to spend a little bit of time contemplating this. Okay, like our angle example here. So this is good stuff. I hope you enjoy these, and I really believe that you will do well.